Algebra focused. I love this lesson because we get to put everything together. Do you remember that? You do. Let there be a continuous function, And I would like to find the slope at point A of the tangent line. Very good with that? So what do we call this right here? We could call it L, and we could call it f of A if it's continuous, has a spot there. Okay. We can't find the slope at one point, so we make another point. Instead of using P's and Q's, I'm using A, and then I'm going to use X. What do we call this spot right here? F of X. Let's allow the beauty to happen. This is going to seem so small and simple and possibly insignificant to you guys, but this is awesome. Okay? I want to find the slope of the secant line because it approximates the slope of the tangent line, correct? All right, let's find the slope. I do y sub 2 minus y sub 1, which would be f of x minus f of a divided by x minus a. That's the slope of the secant line. To find the slope of the tangent line, what do? How do we mathematically bring x closer to a? We slap on a limit. And this is actually definition 1 for what we refer to as a derivative. After we test, we're going to go full board into derivatives for the entire rest of first semester. But this, in essence, is definition 1 for a derivative. And so we're just going to make it happen. It says find an equation for a line tangent to the given function at a point using definition 1. This is all you're going to be doing today. What we do is we take the limit as x approaches what? 1. Why 1? Because x is 1. Of f of x, which is x squared minus 3. Then what? Minus negative 2, so plus 2. Divided by? Minus 1. The x value is our a value. Okay. Notice we get the limit as x goes to 1 of x squared minus 1 over x minus 1. It will always be, in the case of the derivative, that there's a removable discontinuity. Everybody agree that this is discontinuous at 1? The discontinuity is always, 100% of the time, removable, which is just fascinating how that is true, but it never fails. And so now we fill the discontinuity by once we remove it, we plug in 1 and we get 2. 2 is the slope of that tangent line.
Heck yeah.
I like math.
This resembles more what you remember from, kind of our time in college algebra and whatnot, right? A little bit more algebra, okay? Limit as x approaches 2 of Minus 1
Minus 23.
is 23, all over.
X minus 2.
Great. So now I have the limit as x goes to 2 of 3x cubed minus 24 over x minus 2. What now? Limit as x goes to 2. And to be clear, when Danny just said take out the 3, you could put the 3 in front here, or you could put it entirely in front of the limit. Doesn't matter. However you want. I'm going to put it here. And I get x cubed minus 8 over x minus 2. Does x cubed minus 8 factor? It does. What if we didn't remember how it factored? What could we use? Synthetic. So limit as x goes to 2 of 3 times. I have x minus 2. I know that it's an x minus 2 is a clear indication because I have an x minus 2 on the bottom. But what goes here? X squared. What goes on the end? 4. Good. So thank you, Jacob. So no, he says, so that's indication to me we got to talk about. So we square the front, we square the back, we multiply the 2 in the middle. That's the factoring for cubes. Square the front, square the back, multiply the 2 in the middle. The signs are same, opposite, always positive.
Wait, how do we get the second middle one again?
Square the front, square the back, multiply these two together to get that.
Okay.
That's factoring cubes.
You got it.
Those are gone. We now fill the discontinuity. I have 2 squared is 4, plus 4 is 8, plus 4 is 12, times 3 is 36.
Oh, yeah.
Oh yeah. Vector. This is vector stuff.
We're going to skip letter A. We're going to move to letter B.
Okay. Alright.
You feeling bad for letter A?
No.
I do.
Sorry. Limit as x approaches,
Get off your phone, Dan.
negative 1 of
X cubed
plus x
plus 2.
plus 2 divided by
X plus 1.
x plus 1. Do we have a formula for factoring that type of expression?
Yes. There's probably one.
Synthetic.
I'm not really sure.
Synthetic is really the only way that synthetic really is a factoring option. The nice thing is you know it divides by that. Okay, you know it divides by that. So it's really our only technique. It doesn't sound like a factoring option, but it works every time. Negative 1, 1, 0, 1, and 2. Would you have missed the 0?
No.
Never.
As Danny erases.
I wrote a second 0. That's why.
I drop the 1, I multiply. I add. I multiply, add, multiply, add. So I'll write it out. What we have learned is this factors to x plus 1 times the remainder, which is x squared minus x plus 2. That's how this factors. Good with that? The x plus 1s are gone. We fill the discontinuity by plugging in the negative 1. I have 1, plus 1 is 2, plus 2 is 4. Good? Okay, so we've done 3 that are like polynomials. Typically within the calculus course, you've got to be able to make sure that you manage the polynomials, and then we got to be able to do the radicals, and then you got to be able to do the rational expressions. So it actually came to my mind one time, what if this was the 5th root of x minus 2 quantity cubed? Like, then how would that go? And that's a really interesting problem. I was able to work it out, but I'll tell you right now, they could get really tough. So it's like, what's the limit for our content knowledge? And it is dealing with a square root, it's dealing with a rational expression, it's dealing with the polynomial. And those are definitely expected at the college level. Okay? So that's what we need to do. So let's see what happens with the square root piece. I have the limit as x goes to 6 of all over. Pause. Does that expression look familiar to you? Yeah, we've seen it before, haven't we? Notice that when we were working through our limits in the first unit, that we learned to simplify things like that. So you're just doing the same thing. The difference is now you have context of what this means and its understanding. So we're going to build on that as it moves forward. So this shouldn't really be new in terms of actually simplifying this, but in order to simplify this and remove this discontinuity, what do I have to do? Yeah, conjugate, right? Always awkward when you get to a calculus class and at this point you're teaching for the first time to the students what it means to multiply by a conjugate. We saw that multiple times last year and we've seen it this year, right? So now it's old hat for us. Always tough when you're teaching the first time and kids are like, I'm sorry, professor, I don't know what you mean by multiplying by the conjugate. And you're like, shoot, who was their teacher in high school? So we multiply these out, I get x minus 2. Then what? Minus 4. Excellent. So the middles cancel. And that's all going to be divided by x minus 6 times the quantity. X minus 2 plus 2. Does that work out nice and pretty?
Yeah.
The top is x minus 6. The bottom's x minus 6. So I get 1 over, fill the discontinuity, 1 over 4. The algebra calculus truly is absolutely magnificent. I mean, every single time the discontinuity divides out. I love it. Never gets old. No, I have to tell you guys, in all honesty, I was at home last night. I was actually walking out of this building, and somebody was walking up next to me. We were talking, as we do. It was me and Miss Netzer. We're in the hallways. Which, by the way, I think Miss Netzer is one of the best 5 teachers I've ever worked with in my life, ever come across. And she said, "How's it going?" I said, I just love this senior class. They are just the absolute best. You guys really are. You really make it fun. Listen, last night I'm like, okay, what do I have to get excited for tomorrow? I'm like, I get to teach them how to find a derivative by removing the discontinuity. And I know, but it's fun how every time it cancels. Come on, you guys like to do that, don't you?
Yeah.
It brings you joy. You get actually a little dopamine in your brain. You get a little bit of a natural high. And it's fun. It's like, hey, let's get high today, folks, right? Yeah. So it's all a good time. All right, last one. Limit as x goes to 3 of 1 over x minus 1 minus 1/2. All over what?
X minus 3.
Okay, so this one's a rational expression. The rational expressions work a little bit different. Remember back in college algebra, we said we have to learn how to simplify complex fractions. What's the step for simplifying a complex fraction? Common denominators. So I multiply the top and bottom by x minus 1. Top and bottom by dos, which is Spanish for 2. And I get 2 minus the quantity x minus 1 over 2 times x minus 1 all over x minus 3 over 1. Now let's admit it's harder to see how things are going to cancel here, isn't it?
Yeah, it's gonna be okay.
It'll buff.
So it'll buff, yeah. So x goes to 3 of what's in the top? 2 minus x plus 1, which is 3 minus x.
That's okay.
Over 2 times x minus 1. I'm going to save some time here. We don't divide by the fraction, we multiplied by the reciprocal,
Take a negative out of the top one.
take the negative out of the top and cancel.
Negative 1 over 2 of x minus 2.
Sweet.
Love it. We love to see it.
Dang.
I like that.
So, today's assignment, you have 8 problems, and they are all about this type of piece.
Love getting.
This is generally,
Yeah.
It's a dopamine from math.
Yeah.
We're just talking about it.
math dope, math dope is the best. You guys, we need t-shirts. And just math dope
And if you do greater than sign.
is the best. Okay, that's what we need. And the thing is that if we're not careful, somebody will like do that instead. And then
Right.
Right, so let's not.
So let's scratch that. We'll just say it.
Is this the point? So some of my ideas are good and some of them aren't. Is that where we're
I
at?
think they're all good.
I think they're
Everything
all
has
leave a little
plus.
blank.
I think beauty is in the eye of the beholder.
People can pick. They can pick what
Art
they
or
want.
scene? That's
Art.
Who are we to judge, right?
Yeah,
right.
Okay, so in your worksheet, it's set up. Notice that I just give you the A value or the X value. How would you find the Y value?
Plug it in.
Yeah, just plug it in to find the Y value. Okay?
I don't know.
Don't need to do those.
Okay, I tried to, but I
Don't worry
wanted-
about it. You can cross off that for
Maybe
5 and
brown.
6. Yep, don't need it.
Say for which
For your intermediate value theorem,
one? I haven't finished that.
we said, yeah, you already crossed them off. When I say cross them off, rows are right away.
I'm like, you don't have to ask me twice.
Oh no, that ended up on YouTube. Sorry, YouTube. We don't mean to be offensive.
Bye.
Demonetize.
We are just recognizing that you can have natural highs via
Yeah,
mathematics.
cross more.
Yeah.
Another teacher that's like watching this. I hope it gets better. Guys, when I miss this class in college, I'll just-
What? Don't mean, don't.